Chapter 11 is titled Integer Linear Programming. What we're going to do is we're going to apply the same technique and the same things that we've learned for the past few chapters, but we are going to restrict pieces, parts of the problem to a very specific set of numbers. So in some cases, we're going to restrict the solutions or other factors to only an integer. And other times we're going to restrict them to be only binary. So let's just, before we move to the problems, let's just review what an integer is and what a binary number is. So an integer number is just a whole number or non-fractional. In other words, a number without decimals, right? That's the easiest way to explain it. That is not true. That's how we write it. So integer of x, for example, the integer of 5.5 will be 5, right? Because it cannot have a decimal, it cannot be a fraction. That's actually an Excel formula, in case you ever need to use it. It just turns any number into an integer. So examples of integers would be 1. 1 is an integer, right? No decimals. 0 is an integer. 45, -7, a negative number can be an integer. It's just as long as it doesn't have decimals, you're fine. 23, etc., etc. Not an integer. 1.23, that is not an integer number. -2.1. -2.1 is not an integer, not because it's negative, but because you have a decimal, right? 1/3, that's a fraction, right? That's 0.3333. That cannot be an integer. So why are these important? Well, these are important because in some cases, you may want Solver, your linear programming, to give you an answer in whole numbers, not in decimals, right? For example, and this goes back, I think, to the first chapter. If you are in the production of, say, engines, car engines, and you cannot have half an engine at the end of the day, right? Maybe you can, but let's say that you cannot. You cannot have half of an engine because that's just a waste of resources. Then you need to do something in your solver to tell Excel, hey, the solution cannot be a fraction. I don't want half an engine or half a bagel, half a donut, half a cake, or half of something else. All right. So that's what that is all about. Binary number, slightly different. It's related, but it's different. A binary number is an integer, that is true, but an integer that can only take the value of 1 or 0, or its components can only be 1 or 0. This is very anyone that works for IT, anyone that's into computers, they know exactly what I'm talking about, right? So for binary numbers, we only have 0 and 1. For the purpose of solver, and I'm sorry, for linear programming, it's going to be 0 or 1. You don't have to worry about, for example, 1, which is also a binary number because the components are only 1 or 0, but you don't have to worry about that. We're just going to stick to these two, okay? So things that are not a binary, -1, -5, 8, etc. Notice, -1 is not a binary because it has a negative in front of it. 1 is, but not -1. And what is the purpose of this? Why are we going to use this? What kind of product we're going to produce, either 0 or 1? Well, not quite that way. What we're going to do is we are going to use the 0s and 1s as switches. Think of it as the switches that you have on your walls. You probably can see one from I don't know where you're watching this video, but if you're watching this video from home, if you look to your walls, you're gonna see switches for the lights, right? Any switch. Well, that one is probably, I assume, is a toggle switch. So it has two positions, a 0 or a 1. On, off. Is either on or is either off. Is either all in or nothing, right? Think about that. Keep that in mind. Okay, that's what the 0 and the 1. That's what they're going to do for us. We are going to pass along these parameters to solver in a way that solver is going to understand. A 1 means I'll do it. A 0 means I will not do it at all. okay? And then there's going to be repercussions to doing it and not doing it, but that's what those are for. So now we're going to jump to this file. This file is under course documents, so you have access to this file, and just listen to me. And this is one of those things that I will know if you are reading the materials, and I already know each of you by now, but I know if you're reading the materials because I give you so much stuff for the exams, and some of you go to the exams and you're still not doing what I show you previously in a video or something else, right? Here's another example. This file right here, this file that you're looking at right now, has pretty much all the templates that you're going to need for the final, at least for the very difficult problems. This is it. You master this, you shouldn't have any problems on the final, okay? The final, the problems in the final are just going to be just different cases of one of these little ones here. You know, the capital, you see them: capital budgeting as well. Sorry, capital budgeting, fixed costs, supply design, bank location, and there's one more that I don't remember right now. We're going to look at all of them. So let's jump to the how to pass along the instructions to Solver. So here we have a simple problem, okay, and I just pasted the window so you can look at it, but I'm actually going to open the real window. Where's my data? There it is. Okay, all right. So I'm in Solver. Everything here is the same, okay. Up here, that's just the same. Objective by changing the variables, all good. Now, sorry, it's here in the constraints where things start to differ. I have my two constraints, one for less than and one for greater than. The greater is for the non-negativity. The less than is for these 3, 9, 7, and 1. Okay, that should be same as any other problem you've ever done. But look at this. I added a new set of constraints. Okay, what I'm telling Excel here, Solver, look. Where did my window go? I'm having issues. 1 second. There it is. I'm telling Solver that this particular cell, this solution, okay, the solution that I want Solver to give back to me is going to be equal to integer. Okay? You click OK. Why isn't this working now? Oh God, of course. I'm sorry. What am I doing? Integer. Integer. There, sorry. I forgot that I was not coding this. I'm using this window. You select integer, int, and you get this. You click OK. And then I'm going to do it again. You don't have to do it one by one. I could have done the whole range. I'm just doing it one by one so you can see it. See, that one is set it. I'm not going to make that mistake again. Is set to integer. Okay, so when we solve, see, the answer is 309. We told Excel Solver not to come up with a solution that has a decimal. Let's do it again now, but this time we're going to relax that constraint. So we're going to go from an all integer to a mixed case. So I'm going to delete. I'm going to delete. See what I'm doing? I'm just deleting the two instructions that tell Solver that is an integer. And solve. 2.5 and 1.5. Do you see that? So if we tell Solver to use integers, the z is actually lower because Solver is not allowed to go up to certain solutions. And in this case, it will be a 2.5, 1.5. The one before was a 3 and a 0, I believe. We change the constraint, we change the solution.